Hey guys, welcome back everybody. Hope you all are doing great. Today in this video we are going to understand how to merge network of two different companies, or you can say how to merge network of multiple different companies. And this is my scenario for today in front of you. So as you can see, we have two different company here. One is XYZ Corporate and another one is ABC Corporate. Age order of XYZ Corporate is order 1 and age order of ABC Corporate is order number 2. Guys, both companies have their own routing domain. Like you can see, XYZ Corporate uses EIGRP as number 10 for internal routing and ABC Corporate uses EIGRP as number 20 for internal routing. And now we are going to combine these two networks. But guys, before combining the network of two different companies, you have to plan it. You have to plan it like which protocol you are going to run between the companies, what prefixes you are going to advertise between the prefixes, like what prefixes you will advertise from XYZ to ABC, because it is not necessary that your all departments should be able to communicate with ABC Corporate, or all departments of ABC should be able to communicate with all departments of XYZ Corporate, right? We are merging these two network maybe for a specific application, right? For a specific department. So maybe we need to advertise some prefixes from XYZ to ABC and from ABC to XYZ, right? So these things like which protocol will be suitable for you. We have multiple dynamic routing protocol, right? So between router 1 and router 2 we can use any routing protocol, but generally in the real time in the production network, guys, to connect to different companies network, we are using EGP protocol, exterior gateway protocol, right? And exterior gateway routing protocol is BGP, right? Because BGP is responsible for inter-domain routing, right? Here we have two different domain, right? XYZ company have their own routing domain and ABC corporate have their own routing domain. So to make communication possible between two different routing domain, we should use EGP protocol. Otherwise you have to extend either XYZ corporate routing domain or either ABC corporate routing domain. Okay, so I can extend like EIGRP10 to till here to router number 2, right? And then here on router number 2 we can perform redistribution. But again, that is not the way how we are merging two different companies network in the real time in the production network. So according to my experience, here you should use BGP protocol and we will also use BGP. Okay, I will configure BGP between router 1 and router 2, because guys, most of the time I seen people are using BGP to connect different companies network, right? Because it not only we are not using BGP just for making communication possible between two different routing domain. Guys, in BGP we have lots of option for route influence. Like I want to advertise a few specific specific prefixes from XYZ to ABC. So in BGP we will have lots of option to achieve this task. So according to our requirement, you can configure the scenario. So that's why we should use BGP here, because in BGP we have lots of attribute for path manipulation. Then guys, if I will talk about the consideration before merging two different network, or before combining network of two different companies. So like connectivity, first option is connectivity. You should verify the physical connectivity or logical connectivity, because between these two network or between these two companies network, right, maybe their internet can be there, or there can be any service provider, right? Or maybe both companies belongs to same campus, right? So we can connect them together with the help of physical cable as well, right? So either we can connect these two companies together physically, right, or logically. With the help of service provider you have connectivity, then you can configure the tunnel, right? And on the tunnel you can run the routing protocol. So first consideration is connectivity. You should you should plan how you are going to connect two different companies network together, right? What service provider you are going to use, because on the basis of connectivity we will decide rest things like the protocol, right? The security, policy based routing, or we can say redundancy. Okay, like between R1 and R2 I can have two different service provider like internet and MPLS, right? Internet, let's say internet is my primary ISP and MPLS is my secondary ISP, or MPLS is my primary ISP and internet is my secondary ISP. So first consideration is connectivity. We should focus on connectivity, how we are going to connect it, right? Either we can connect to companies network physically or logically. Then we should plan for routing protocol, like what routing protocol I am going to use here, right? So according to your requirement you have to decide which routing protocol is suitable for your companies, right? So I am going to use BGP protocol here. So routing protocol is BGP, and the connectivity is physical, right? Physically both companies networks are connected together. Then guys, IP management, like what IP addressing you are going to use between the companies, right? Make sure IP addresses are not complete, are duplicate, right? And how you can avoid the wastage. After that we should work on security. We should plan security, how we are going to secure it. Because see, maybe your internal network is secure, right? Both internal network are secure, you have configured the lots of security policies there, but as you are going to implement new connectivity between these two buildings, again you have to work on security, how you are going to secure it. Like if you are using BGP routing protocol here to exchange the route, so you should configure authentication in BGP, right? So what can be the plan for security? That is also one consideration. Then policy based routing, what prefixes we are going to advertise between these two companies, right? Like let's suppose we have some application in XYZ company, and the all users in ABC as well as in XYZ should be able to access those servers, right? So we need to advertise a specific prefix, a specific subnet from XYZ to ABC. In the same way, inside the ABC corporate we have a few specific departments that should be reachable from everywhere, so we are going to advertise only those prefixes. So how to configure policy based routing? So you have to plan policy based routing, and according to your requirement you will configure policy based routing. Then guys, redundancy is also important. Why redundancy is important? Because see, as you are connecting two companies together, and let's say you have only one path, so what will happen if any link between edge routers of both company will goes down, or if any device will fail, then the connectivity between XYZ and ABC will goes down. So right now you can see I'm using two link between router 1 and router 2, right? But let's suppose, as I told you, you can have different service provider for the connectivity. So you can use internet and MPLS, you can use the broadband, right? So then in the last you should focus on redundancy. After that, after deciding these all, what will be the redundancy, IP management, security, routing protocol, connectivity, how we are going to connect it. Now after deciding these all, we should plan, right? We should draw a diagram of our network, how I am going to connect it. Like you can see, this is the network diagram, right? This is the network diagram. According to this diagram I am going to implement devices in the rack, right? So guys, first thing is plan and then design. Network designing means how you are going to connect the devices. After that implementation, how we are going to implement it, then we will test it, will verify that everything is working fine or not. After that deployment, right? The means monitoring the network, how you are going to monitor it and how you are going to maintain it, right? Maintenance part, right? So these are the consideration before configuring the network, and hope these are clear to you. As you can see, between router 1 and router 2 I have two link guys. One is the upper link and one is lower link. Upper link is connected with f2/0 f2/0 on both router, and lower link is connected with f1/1, right? And as I told you, I am going to use BGP protocol here, and let's suppose I'm going to use upper link as a primary link, right? I will configure the scenario in such a way so that upper link will work as primary link. Let's say here bandwidth is 40 Gbps, right? Here bandwidth is 1 Gbps in the lower link, right? So lower link is my backup link. If primary link will goes down, then these two companies can communicate with the help of backup link. After that, for the security purpose, we will configure password in BGP, right? And then we'll use different tools to troubleshoot it, right? To test the network. We can use ping or we can use trace route, right? To verify the path. Now, without wasting our time, let's begin. First of all, guys, see, I have access of both edge router, router 1 and router 2. If you will check the routing table of router 1, so IP route, you can see we have some prefixes from EIGRP, right? So as you can see, in XYZ corporate, I am running EIGRP number 10, guys, and here we have multiple departments like HR department, sales department, admin department, and server department. Inside the HR department, we have different subnet, that is 10.1.1.0/24. So you can see all departments are isolated with each other, right? So for the security purpose, for the better performance, we have isolated each department. Okay, for the sales department, we have this subnet 10.1.2.0/24. For the admin department, we have this subnet 10.1.3.0/24, and for the servers, we have 10.1.4.0/24. In the same way, in ABC corporate, we have different departments like finance, where I am running subnet 20.1.1.0/24. Then management, where I am running subnet 20.1.2.0/24. Then sales department, where I am running network 20.1.3.0/26. I think these are 24 here in the voice 20.1.4.0/27. So according to the number of users, number of valid IP addresses, you can decide the subnet mask, but I think these are /24 only. Let me configure it 24. And on router number 6, you can see, let's suppose router 6 is connected with a different company, right? And that company is advertising these subnets 50.1.1.0/24 to 50.1.6.0/29. So we can create these loopback on router number 6, right? And after that, we'll configure the BGP, and we will create some scenarios like, let's say router 1 should not advertise, router 2 should not advertise 50 prefixes, because 50 prefixes are required for these departments only. Only these departments need to communicate with these user. So how to configure the scenario so that router 2 will not advertise 50 prefixes, or only it will advertise connected prefixes or received prefix from router number 5 or from the router number 6. So now, without wasting our time, let's begin. Hope topology is clear to you. So on router number 1, you can see we have some connected network, directly connected networks, and we have some received networks like learn network from the neighbor router. So IP route EIGRP, you can see these are learn prefixes on router number 1. So router 1 is learning these networks from their EIGRP ES number 10 neighbors, right? So router 1 have two neighbor, router 3 and router 4. From these two neighbors, router 1 have learned these networks information. In the same way, on router number 2, so IP route EIGRP. So you can see router 2 have also some prefixes in the routing table, guys, and it have learned from the EIGRP, right? So IP EIGRP neighbor, you can verify the neighbors, and if you want to check the ES number here, so IP protocol, you can see the ES number is EIGRP ES number 20. And if you want to verify which type of neighbor these are, so simply you can run command so IP-EIGRP neighbor detailed, and let's say on F0/0 fast ethernet 0/0. So these are the information of neighbors. Done, guys. But on router number 2 we don't have 50 prefixes. Simply what we can do, we can access the router 2. And before that, if you want to verify the subnet mask of learn routes, so you can open any network, any subnet in the detail, like so IP route, and let's say 20.1.1.0 subnet mask 255.255.255.0. So you can see the subnet mask is /24, right? 255.255.255.0. And what about the other network like 4.0? 4.0, yes, here also you can see subnet mask is same. Okay, so this is how we can open a network in details in the routing table, and these are, guys, very important for troubleshooting, right? Whenever you are connecting to network, to different companies network together, first of all, as a network engineer, you have to familiar with the internal network, right? With the internal routing, what routing protocol running, right? Like everything about the routings and switching as well. Okay, on the switches, what VLANs are running. Okay, because we have separated each department with the help of VLAN only here. So you can see this router have learned this network 20.1.4.0 from 26.1.1.6 from this neighbor. Okay, now so IP route in the routing table, you can see on the in the routing table of router 2 we have information of only ABC corporate, and on router number 1 so IP route we have network information of ABC XYZ corporate only, right? And what about the between router 1 and router 2? So IP interface, or before that even you can check so interface status, and let me say include connected, show me the connected interfaces only. Okay, so connect, what happens, so interface status, so interface status include connected. On router number 1, why I'm not able to run this command, so interface status. So like this you can check the connected interfaces F1/1 and F2/0. These two interfaces are connected with edge router of the ABC corporate, means router number 2. So you can see the status, you can check the status and line protocol of these two interface. But here why I'm not able to see the output. So interface status, there should be on command like this, but here I am not able to see that command. Okay, you can run command show IP interface brief, let's say include or include assigned only, show me the assigned interface. These are unassigned interface. So we can say up interface, like show me the up interfaces. So you can see fast ethernet 0/0, fast ethernet 1/0, fast ethernet 1/1, and fast ethernet 2/1. These interfaces are up on router number 1, guys, and all the interfaces we have configured the IP address. So on F2/0, which is connected with router number 2, that is upper link, what is the IP address there? 12.1.1.1. So you can see on the upper link I am running 12 network, and on the lower link I am running 21 network. So on F1/1 you can see IP address is 21.1.1.1, and on router number 2 so IP interface brief exclude unassigned. So you can see again on F2/0 IP address is 12.2, and on F1/1 IP address is 21.2. So let me verify the connectivity between R1 and R2. Ping and 12.1.1.2. So you can see I'm able to ping, success rate is 100%. So IP ARP, it have resolved the MAC address 12.1.1.2. MAC address of router 2 is this one, and in the same way we can ping from the lower link also to R2, ping 21.1.1.2. So this ping should also work. Just wait. Yes, you can see ping is working. That means now I can configure any routing protocol between router 1 and router 2. Now guys, on router number 1 we are going to form two BGP peers, right? Two BGP peer, one BGP peer on the upper link on F2/0 and one BGP peer on F1/1. So let me configure the BGP on router number 1. Let me take you to config T, configure terminal mode, and say router BGP, and let's suppose on router number 1 I am going to run BGP number. Here BGP number is BGP, just wait a minute. Here BGP number is, let's say, 100, or you can use the private number. And on router number 2 I am going to use BGP number, let's say 200. Okay, so we'll form eBGP peer between router 1 and router 2. You can form iBGP neighbor as well. Router BGP number 100 and say neighbor, IP address of neighbor. Guys, either we can form neighborship with the help of loopback interface. I can create one loopback on router 1 and router 2. Like you can see, we have multiple links between router 1 and router 2, right? So if you will configure a neighbor on the physical link, then again there is some issue. If link will goes down, then neighborship will goes down. But as you have multiple link, so if you will form BGP neighborship with the help of loopback interface, then until and unless there will be reachability between router 1 and router 2, your BGP neighborship will be up. But don't worry, here I am going to configure BGP neighborship through the physical IP address, which is running on the physical interfaces of routers, because here I will form two BGP neighborship, right? But again, with the help of loopback interface, if you will form BGP neighborship, then you have to configure one IGP routing protocol first. Your IGP protocol can be OSPF, EIGRP, right? So neighbor, who is the neighbor? 12.1.1.2 is the IP address of router 2, and then say remote ES. Remote ES of means of this neighbor is 200. On router number 2, I am going to run BGP ES number 200. So neighbor 12.1.1.2, remote ES 200. Then neighbor 12.1.1.2, and let's say password. Password is Cisco @123. Let's suppose you can configure any password here. Then neighbor, and see we have multiple options to configure here with this neighbor 12.1.1.2, and put question mark. See, lots of commands are available, like what prefix you want to advertise with this neighbor, you want to activate this neighbor. Like by default for IPv4 neighbor is activate command is already enabled, but if you are configuring for IPv6, then you have to enable it manually. Then advertise map, so we can use local AS command, right? We can use the route map, we can use different services here. And now you can see I'm getting error message here. What is the error message? Because here I have configured the password for this neighbor, and that password is not configured on router number 2. What it's saying, no MD5 digest from 12.2. So don't worry about this neighbor. Now here I am not going to configure anything else. Let me configure another neighbor, that is 21.1.1.2, right, on the lower link, and remote ES is again 200, and neighbor 21.1.1.2, and say password is again Cisco @123. First of all, we will up the BGP neighborship, then we will see the rest configuration. Now let me take you to router number 2, and on router number 2 say router BGP ES number 200 and neighbor 12.1.1.1, and remote ES of this neighbor is 100, right? And then neighbor 12.1.1.1, and say password is Cisco @123. Done, guys. Now second neighbor on the lower link, neighbor 21.1.1.1, and remote AS of this neighbor is again 100, and neighbor 21.1.1.1, and set password Cisco @123. So I have configured the password, I have configured the neighbor command, and now you can see neighborship is up, right? So how to troubleshoot BGP neighborship? If BGP neighborship will not come up, first of all you should check the TCP connection, because BGP is an application layer protocol which uses TCP service at transport layer. So we can run command show TCP brief, and now you can see we have, guys, logical connection between router 1 and router 2, TCP connection, right? So 12.1.1.1 and 12.1.1.2 we have BGP neighborship, and 12.1.1.1 is using random port number, and 12.2 is using well known port number of BGP, and state is established. So you can see we have TCP connection. So now these router 1 and router 2 can exchange messages of BGP, right, with the help of this session, right, with the help of this TCP session. In the same way, here you can see we have one more session, and this time router 1 is using well known port number, that is 179, and router 2 is using random port number, right? On the router number 2 also you can verify it. So TCP brief, this is troubleshooting command to troubleshoot the BGP session. Okay, so you can see 12.1 is using well known port number of BGP, and 12.1 is using random port number. And this time on the lower link, router 2 is using random port number, and router 1 is using well known port number, and again status is established. Done. So as we have TCP connection, now this router can exchange the message of BGP. So both router will exchange open message, and then it will form the neighborship. So I can run command show IP BGP summary to check neighborship, and you can see here we have two neighbor on router number 1, 12.1.1.2 and 21.1.1.2. Done, guys. Now as I told you, I want to configure upper link as primary link and lower link as a secondary link. So what I can do, I can create I can set the higher uh, local preference value on the upper link to make the upper link as primary link, and we can leave the lower link on default, right? By default local preference value. So what I can do, simply I can configure, I can create one prefix list here, or let me get the route map, and name of route map is, let's say, set underscore, and what can be the name can be anything. Let me say set primary path, and then the action permit, after that sequence number is, let's say, 10. Here I am going to say match, let's say, IP address from prefix list. From prefix list I can create one prefix list with any name, let's say all routes. So it will match IP address from prefix list all route, and then I am going to say set local preference value, let's say 200. Done. Now I need to create one prefix list, so say IP prefix list, and the name of prefix list is all routes, and here I am going to say permit anything, all network /0 and less than equal to 32. Like this we can create the prefix list and route map to make upper path as the primary path. And now I am going to call this route map with the neighbor. So go to router BGP, again AS number 100, and what we can say, we can say neighbor 12.1.1.2 the IP address of router 2, and use route map. This route map, name of route map is set primary path. And guys, then direction, in which direction? So whenever router 1 will receive prefix from this neighbor, it will call to this route map, right? Done. So now whatever prefix router 1 will receive from router number 2, it will use route map in direction, right? Means for the received route. And inside the route map we have advertised all prefixes, right? It is matching all prefix with the help of prefix list. and then it will set the local preference value 200. Done. Now in the same way on router number 2 also we need to configure one route map. So let me copy the configuration, do so history, and I am going to modify some information here. Copy, and let me open the notepad. So on order number 2, again name of route map is same, action same, permit and match IP address prefix list is also going to be same, set local preference value 200, and done. Only thing is router BGP number 200, and I am going to apply it with which neighbor 12.1.1.1 in the indirection. Let me copy the command and let me paste it on router number 2. Paste the command. Done. Now to verify it, simply you can run command show IP BGP neighbor on router number 1, so IP BGP neighbor, and if you want to check the commands, whatever commands I have enabled here, so run section BGP, you can see neighbor 12.1.1.2 remote AS, this one neighbor 12.2 password, neighbor 12.2 route map, set primary path direction in, and then for the lower neighbors, means neighbor on the lower path, I have enabled only two commands, right, remote AS and the password. In the same way on order number 2 also you can verify. Then next verification command can be show IP BGP neighbor. We can use this command. So this command will give you the detailed information of neighbor, guys. Like you can see BGP neighbor is 12.1.1.2 whose remote AS is 200, and which type of neighbor it is external neighbor, right, BGP version 4, and router ID of the remote router ID is means router ID of router 2, neighbor router ID is 26.1.1.2. then state of this neighbor is established, neighbor is up till 6 minute and 41 second, last read, you can read this information, hold on time, and the neighbor session one active note, okay, neighbor capabilities, route refresh, advertise and receive new, done. Where is the route map configuration, and you can see how many update message it have received from this neighbor, how many open message it have sent and received. So it have till now it have sent only one open message and it have received one open message, right. Then zero notification message, zero update message from one update message it have sent to their neighbor and it have received to their neighbor. How many keep alive message it have exchanged, 9 keep alive message and 0 route refresh message. So total number of messages that this router have sent to this neighbor is 11 and it have received 11, right. Then default minimum, this leave it for now. So you can see address family of this neighbor is IPv4 unicast, session done, table version 1. So there are many informations. Now here I want to show you something. Refresh activity, address tracking is enabled, okay. Minimum incoming TTL 0, outgoing TTL 1. SRTT time, RTO time, and after that another neighbor 12.1.1.2. So here we are not able to see the route map information for the neighbor. Let me use the another command that can be show IP BGP. So there is no any network under BGP table, right, definitely. So IP BGP neighbor, and then we can put the IP address of neighbor 12.1.1.2 and routes. So received route is 0 from this neighbor, or advertised route is also 0. Then we can say 21.1.1.2. Like this we can check the neighbor information and then we can say route, so 0 route. Like this we can check the neighbor information. Here we are not able to see the route map configuration, so you can run command so run section BGP, right? In the same way you can verify on router number 2 also. So now guys, between router 1 and router 2 BGP neighborship is up. We have BGP peer, so IP BGP summary on router number 2 also you can see, and state is working fine, right? Neighborship is up, both neighbors are up on the both link. Now I am going to advertise networks in the BGP. Okay, so on router number 1, let me advertise networks in BGP. So IP BGP, now you can see we don't have any prefix. Config T, and then router BGP S number 100. And guys, in BGP S number 100 I am going to advertise 10.1.0.0 and mask 255.255.0.0. You cannot run command like this, because see, if I will hit enter here, it will not advertise any prefix in BGP. So IP BGP, you can see we have multiple options to advertise networks in BGP, but make sure whatever network you are advertising in BGP, that network should be present in routing table with same subnet mask. So there is no any route available in the routing table with this subnet mask, guys, right? With 255.255.0.0. Do so IP route, you can see, right? 10.1.1.0, these networks are there with /24. So I'm going to remove this command, say no to this command, and then I'm going to say network 10.1.1.0 and mask 255.255.255.0. Now if you will check BGP table of router 1, so IP BGP, so you can see this router have installed this network in the BGP table, right? And next hop IP address for this network is 13.1.1.3, the IP address of router number 3, because of a network in routing table. So IP route, you can see this network 10.1.1.0/24 is present in the routing table of router 1, from which what next hop 13.1.1.1. So with the help of same next hop, it have advertised in their BGP table. So IP BGP. Now if you want to verify the BGP table of router 2, simply you can run so IP BGP command on router number 2. But before that, see, this is the network information, and this network is valid as well as best. And next up is 13.3 router 3, and metric for this network 30720. And guys, metric over here you can see is same, right? From the EIGRP, router 1 is learning this network information from EIGRP with this metric, right? So BGP is also using same metric here, right? And then weight value, this is default weight value, and for the advertised prefix, local preference value is nothing, and then path, right? Now guys, on router number 2, so IP BGP, you can see router 2 have received this network information from two neighbor, right? From 12.1.1.1 as well as from 21.1.1.1, right? So router 2 have two BGP neighbors, so IP BGP summary, and it have received the network information from both neighbor, same network. But best is via which router? Best is via router 12.1, means from the upper path, right? So router 2 is going to install this network in their BGP routing table on which path? On the upper path. The reason, local preference value, here you can see, here I have set local preference value 200, right, for this neighbor. And here on the lower path you can see local preference value is nothing. So you can verify the routing table. So IP route BGP, and you can see this network 10.1.1.0/24 is reachable via 12.1.1.1, and 12.1 is reachable from router number 2. So router 2 can forward traffic in this network now, right? To verify it, I can ping 10.1.1.254 is the last IP address of the subnet is running on LAN interface, right? Last IP address is the gateway IP address. See why I'm not getting the reply message, guys? Because router 3 don't have 2L network. When I am pinging this IP address 10.1.1.254 from router number 2, it will set source IP address as IP address of their exit interface, right? Exit interface IP address is 12.2, and on router number 3 route is not available, right? So LAN users can ping to 12.1, but router 2 can 10.1 254, but router 2 cannot ping it, right? Now will router 5 receive this network information? On router number 5 you can verify the routing table, so IP route and 10.1.1.0 255.255.255.0. You can see this network is not in table, right? So why this network is not in table, guys? Because between router 2 and router 5 we are running EIGRPS number 10. So now we need to redistribute BGP into EIGRP on. So let me take you to router number 2, and on router number 2 I am going to redistribute BGP into EIGRP. For now, if you will check EIGRP table of router 2, so IP EIGRP, let's say topology table, right? So in the topology table you can see this router have not installed 10 network, right? Or simply I can check like this also, 10.1.1.0 255.255.0. So entry is not available. Now I am going to redistribute BGP into EIGRP. So here I am running EIGRPS number 20. So go to router EIGRPS number 20 and say redistribute BGP. What is the AS number of BGP on router number 2? 200. And guys, whenever we are advertising route in EIGRP, we have to define the K values, because EIGRP uses K values to calculate metric. So let me define the metric component, metric, then K1. K1 is, let's say, 10,000 kbps. After that it will ask you for the load, so let's say delay is, let's say, 10. And then we can define the reliability, let's say 255. After that it is asking for load 255, and then MTU is, let's say, 1500 bytes. Now you can check the router 5. So IP route, you can see this time route is available for 10.1.1.0/24, and this network is reachable via which IP address? This network is reachable via 25.1.1.2, which is IP address of router 2, and 25.2 is reachable from here, ping 25.1.1.2. So now can router 5 ping to router number 3. See guys, here on F0/0 of router number 3, on this interface I am running last IP address from this subnet. So IP address of this interface is 10.1.1.254, and IP address of this interface is 20.1.1.254. So can these two IP address communicate with each other? Ping 10.1.1.1 and source 20.1.1.1. Ping is, sorry, not 20.1 and 10.1, 10.254 and source 20.254. See, ping will not work. The reason, router 5 have route, right? Router 5 will forward traffic to router 2 will forward it to router 1 will forward to router 3. When router 3 will generate reply, that time router 3 will generate reply for 20.1.1.254, but on router number 3 route is not available. So on router number 3, see, so IP route 20.1.1.0 255.255.255.0 route is not in the table. So on router number 2, now I am going to advertise 20 network in BGP, right? So router BGP AS number 200 and say network, which network? 20.1.1.0, and say mask 255.255.255.0. Now so IP BGP, here you can verify the BGP table. So IP BGP, so it have installed this network in BGP table, you can see. And next up IP address is router number 5, and again metric is same, metric of EIGRP and the weight value, right? Now if it router 2 have installed this network in BGP table, that means it is going to advertise to their neighbor as well. And so IP BGP summary, router 2 have 2 BGP neighbor, 2 peer, so router 2 is going to advertise it to their both neighbor. And now you can check the BGP table of router 1, so IP BGP. So yes, router 1 have learned this network 20.1.1.0/24 from 12.1.1.2 as well as from 21.1.2, right? So on both link, on the upper link and lower link, router 1 have learned 20 network. But which one is the best, guys? Best is via 12.2, means on the upper link. The reason, local preference. As I have configured upper path as a primary path and lower path as a secondary path. So router 1 is also going to install this network. So IP route in the routing table from the primary link. So 20.1.1.0 mask 255.255.255.0. Yes, you can see next hop IP address is 12.2 and 12.2 is reachable from here. But router 1 will not advertise it to router number 3 because between router 1 and router 3 I am again running EIGRP, right? So what we need to do, we need to redistribute BGP into EIGRP here as well. So let me take you to router EIGRPS number 10 this time. Say router EIGRPS number 10 and I am going to say redistribute BGP AS number 10 and again let me define the metric components. So metric components means first one is bandwidth 10,000 kbps, then load 100, 255 is reliability, load 255 and MTU 1500 bytes. Now so IP EIGRP topology and 20.1.1.0 255.255.255.0. So you can see this router have installed this network in their topology table, right, via upper link, right, on the upper link via 12.2. So IP EIGRP topology, in the topology table also you can see here this network state is passive, so everything is fine here. So IP route BGP in the routing table also you can see next hop is 12.2 and now router 1 will advertise it to router number 3. So let me take you to R3 and this time again I am going to check routing table. So this time you can see route is available for this network and next hop is router 1 13.3. So now router 5 can ping to router number 3, right, ping 10.1.1.254 source 20.1.1.254 and see this time ping is working. So guys, in the same way now I am going to advertise rest all prefixes in BGP. So on router number 1 config T router BGP AS number 100 and say network 10.1.2.0 and mask 255.255.255.0, the network 10.1.3.0 and mask 255.255.255.0. Now so IP BGP, so you can see these are advertised prefixes on router number 1 and this is LAN prefix, right? Now router 1 is going to advertise these all prefixes to their neighbor, to their both neighbor. This router have two neighbors, so IP BGP summary, right? But again router 1 will learn this network from the both neighbor, but it will install in the routing table via one neighbor, right, via upper link, on the upper link. So to verify it, simply let me take you to router number 2 and so IP BGP. So you can see for all 10 networks best path is via 12.1.1.1 12.1.1.1. So IP route BGP done. It have installed all 10 networks via router number 1 and then it will router 2 will advertise it to router number 5. So IP route BGP, sorry, not BGP, so IP route EIGRP, because router 5 will learn through EIGRP. So you can see this router is learning some external prefixes, right? These three are external prefix. So AD value is 170 and now router 5 can forward traffic for this network. In the same way you can verify the routing table of router 6 as well, router 6. So let me access R6 and on router number 6 also, so IP route EIGRP. So here you can see we have some external prefixes done. But on router number 3 and on router number 4, so IP route EIGRP, we have only one external prefix, correct? So now I am going to advertise rest all prefix on router number 2 into BGP. So config T router BGP AS number 200 and say network 20.1.1. sorry 2.0 and mask 255.255.255.0. in the same way 20.1.3.0 done. So IP BGP, so you can see these are advertised prefix and these are learn prefix, receive prefix. So now router, it will advertise to router number 1 and on router number 1, so IP BGP. Again guys, On router number 1 we have only these two network information. Just wait for some time, it should advertise one more network, 20.1.3. Yes, now you can see all 20 networks are there in the BGP table of router 1, and best is via 12.2, means from the upper link. So it will install in the routing table. So IP route BGP. So you can see these all prefixes are reachable via 12.2, means from the upper path. And now you can verify the routing table of R3. So IP route EIGRP. So this router is learning 3 external prefix. In the same way router 4 will also learn all the prefixes, all external prefixes. AD value is 170. Done. So now these all departments are able to communicate with each other. We have merged these two companies together. Now to verify the connectivity, let me take you to router number 5, and from the router number 5 I am going to ping, let's say 10.1.2.254 and say source 20.1.2.254. So you can see management department and sales departments are able to communicate. This management department of ABC corporate and sales department of XYZ corporate, these two departments are able to communicate. In the same way, management user can even ping to admin department 3 and 4. So we have not, I think, advertised 4. Yes, we didn't advertise the 4.0. So IP BGP, yes, you can see 4.0. So we need to add one more network command here, router BGP ES number 100 and network 10.1.4.0, say mask 255.255.255.0. In the same way on router number 2 also, router BGP ES number 200 and network 20.1.4.0 and say mask 255.255.255.0. Done. Now go to router number 5 and let me ping again. You can see ping is working, right? In the same way from other router also, like from router number 6 also, we can verify. Router 6 is connected with two departments, sales department and voice department in ABC corporate. So let me ping 10.1.1.254, means I'm pinging to HR department in XYZ corporate, and say source 20.1.2.250, not 2, 3.254, and see ping is working. Even voice department, voice servers can also ping 4. See, means now all departments are able to communicate with each other. So hope this is clear, guys. Now we have merged these two network together. Now let's understand some additional configuration. Right now both departments are able to communicate with each other. Now I am going to verify that if primary link will goes down, then and users are able to communicate with each other or not. So let me do one thing. On router number 1 I am going to down f2/0, which is the primary link. So interface f2/0, and so IP IP route BGP. So you can see all 20 networks are reachable via 12.2, right? And guys, on this router we have two BGP neighbors. So IP BGP summary, right? Two neighbors. Done. Now I am going to say shut down here. So BGP peer will goes down. Yes. And now again let me check the routing table. So IP BGP. See, this neighbor is now idle. This neighbor is idle. So sometime in real time also you will see neighbors are idle, guys, and you need to troubleshoot it. Idle means BGP is trying to form the neighborship, right? Maybe router is not able to establish TCP connection. That means there is some issue with connectivity. Maybe you are not able to ping the neighbor IP address, right? Or TCP port number is blocked, right? Reason can be anything. Done. So as this neighbor is now idle, primary neighbor is idle, it will install all received route from the secondary link on the secondary link. So IP route BGP Now you can see all 20 networks are reachable via 21.1.2 from the lower path. Done. Again, when upper path will come up, and this time do so IP BGP. You can see local preference value, do so IP BGP. Do so IP BGP. Local preference value is nothing here, right? So that's why again when primary link will come up, do so IP BGP summary. Now you can see this neighbor is still idle, just wait for some time. Yeah, now you can see state is active, and now neighbor is still idle. 12.2, wait for some time. Yes, now you can see received route is 4, so it have received 4 network information from this neighbor. BGP is slow routing protocol, guys, slower than OSPF, so that's why sometime we are not, it is not like everywhere I am going to use BGP only, right? As I told you, here I am connecting two different companies network, so in this scenario I will use BGP, right? But inside the network, inside the, for the internal connectivity, I will prefer OSPF because OSPF is faster protocol as compared to BGP. So IP BGP. Now you can see again best path is via 12.2 and do so IP route. So here failover is working fine. You can see the BGP route. All prefixes are reachable via 12.2. On router number 1 failover is working fine. Let me check failover on router number 2. On router number 2 again I am going to down interface f2/0, and before running shutdown let me check so IP route BGP. So till now, till you can see all prefixes are reachable via 12.1 means via upper link. Now let me say shutdown, right, and do so IP BGP summary. So you can see this neighbor is idle. 12.2 is now idle again. So do so IP BGP. Now it is learning prefixes, all 10 prefixes from only one neighbor 21.1. So it will install this network information in routing table. Done. So on router number 2 also failover is working fine. Again I am going to say no shutdown, right? And guys, there are some debugging command also that we can use to troubleshoot the BGP, right? Like BGP routing protocols are keep sending keep alive message. So to check the keep alive message, simply I can say debug IP BGP and not IP debug BGP, then IPv4, then we can say here what unicast multicast. I think here I should use debug IP BGP, then keep alive like this. Now you will see this order will generate one keep alive message for their neighbor. Actually it will generate two keep alive messages because order one have two BGP neighbors. Or we can use so log command as well to check logs. See the log messages, line protocol, BGP EIGRP message, BGP neighbor message, keep alive timer failed. Okay, these are earlier logs messages. So you can see the log messages, and this router is sending the keep alive. To disable the debugging I can say on all, right? This is not recommendation in real time to use debug command because it will increase the CPU utilization. Now guys, on router number 2 let me check 50 networks are there or not. So IP route and 50.1.1.0 mask 255.255.255.0. so now you can see this network is not in table. Now let me take you to R6, and so IP interface brief exclude unassign. So 50 networks are not available here. So what we need to do, we need to create some loopback interface here, and on those loopback interfaces we can add the networks. So we will configure the rest thing in another video, guys, because see the video length is I think already 1 hour. Yes, so we'll continue this video in part 2. I will create part 1 and part 2 of this. Okay, so today we have seen how to merge two network of two different companies. Now guys, if you have learned something from this video, please hit on like button. If you have any question, query, concern, please let me know in the comment section. If these type of videos are helpful for you and you want more videos like this, please type yes in the comment section. Once you will type yes in the comment section, I will get to know that these videos are helpful for you, and it will motivate me to make more videos like this. Okay, so hope this. And guys, the last thing is, if you are looking for any live training, right, like let's say live training of CCNA or CCNP, service provider, data center, SD-WAN, so you can visit pmnetworking.in. I am starting new batch of CCNA soon, so you can check the start date and time on pmnetworking.in. This is my website. Let me show you. Here is the website, PM networking. Simply you can type PM networking in the browser and see this is the website. So on the website you can see there are various courses available under live training. So this is my website, and under the courses you can see we have two types of course, live training and self-paced. So for live training you can check live training courses, and these are the courses. CCNA, I am providing complete CCNA in 10,000 guys, at 10,000, so anyone can afford it, and one batch of CCNA is starting soon, right? So like if you are not able to understand these types of concept, right, like BGP, so it is not possible to learn complete BGP or complete course CCNA and CCNP from the YouTube. No, right? You can't learn complete course or even a complete protocol. I know multiple videos are available on the YouTube, but guys, YouTube is good for revision, for learning a topics, not for learning a complete course. So if you want to learn the complete course, if you are beginner, fresher, and if you know anyone who are beginner who want to make their career in networking domain, you can refer them to PM Networking. PM Networking is the fastest growing institute in 2023 to 24, and we are putting lots of effort to teach people networking so that they can grow their professional life in the industry. They can get job in the top MNC's company. Okay, so that's all. If you are looking for any live training, just visit to pmnetworking.in and enroll yourself for the course, whatever course you want to join. Okay guys, thanks for watching. That's all. We'll meet soon in next video. Till then, stay safe. Bye bye.